Okay, this is going to be the Algebra 2 2018-2019 video on composition of functions. Okay, some new stuff for this year. Some stuff has been taken out. Okay, all right. So g of x minus h of x. So that's going to be x squared minus 4 minus 2x minus 1. Okay. The way you handle this is you like terms. So x squared minus no x squared would just be x squared. Okay. Negative 4. Okay. Negative 4 minus negative 1 would be negative 3. And then I don't have an x, so I will treat that as a 0. So 0 minus 2x, or minus 2, is negative 2, so it's negative 2x. Should probably write it in order with the x's. Okay? This is going to be f plus g of x. So 4x plus 7 plus x squared minus 4. The x squared, 4x plus no x over here would just be 4x. 0 plus x squared would just be x squared. 7 plus negative 4 is 3. Okay? So what you can do here is you can just, like on this one, you can treat it like this is 0x and this is 0x squared over here, just so you have the terms. Same thing here. This would be 0x squared, okay? And then 0x. So if you need that, okay? All right. I'm going to stay over here just so I can slide the component down. All right. I got g of f of x. So this is the function that I start with, and I replace the x's with parentheses. So I'm going to start with this, and what I'm going to do is I'm going to replace the x's with parentheses. Then this letter is what I fill in. Okay, which is 4x plus 7. All right, now, when you have an x here, that means you have to do algebra. All right, so the squared means 4x plus 7, 4x plus 7, 4x times 4x would be 16x squared. 4x times 7 would be 28x. Let me clean this up a little bit. It's a little small, the writing is. 4x plus 7, 4x plus 7, that's 16x squared. 7 times 4x would be 28x. 4x times 7 would be 28x. 7 times 7 would be 49. Okay? Now, what you're going to do is combine all the like terms, including this one right here. So there is no 16x squared. There's another x squared term, so I got that. 28 plus 28 is 56x. And 49 minus 4. 45. H of g of x, okay? So what I would do is even though it's written a little bit different, this is what I'm going to start with. This is what I'm going to fill in. This means I do algebra. Okay? So I'm going to start with h of x, which was 2x minus 1. So instead of 2x, I'm going to have 2 parentheses minus 1. I'm going to fill in g of x. G of x is x squared minus 4. Okay? Now what I would do with this one is I'm going to distribute, which would be 2x squared minus 8, with this minus 1 out here. And then what I'm going to do is, the like terms are 8 minus 8 and minus 1. So it's going to be 2x squared minus 9. Okay? This is f of k of 6. Now, this is the start. Okay, this is what you fill in. This means we're going to go to the calculator, okay, and put that in, okay? So I'm going to start with f, which is 4x plus 7 but instead of 4x plus 7, it's 4 plus 7. I'm going to put k in there. K is square root of x plus 3. Okay? Now, so the 6, here's what that means. What I'm going to do is I'm going to go to the calculator, go 6, arrow, x, execute. Then I type the problem in, just like I see it, into the calculator. 19 is my answer. So you should get a numerical answer. When you have the calculator, your answer, okay, should be a number. All right? Okay? This is h of f of 5m. So this is what I start with. Okay? All right, I'm going to start with h. I'm going to substitute f, and then I'm going to put 5m in. So h is 2x minus 1. F is 4x plus 7. Now, what you do with this 5m, okay? So you're like, Mr. Evans, this has a number and a letter. So what we're going to do is we're just going to replace the x with 5m. Okay? So what that's going to be is that would be 20m plus 7 minus 1. I would distribute that, so that's going to be 40m plus 14 minus 1. Okay? I'm going to use the calculator. Use your calculator for as much arithmetic as you need to. 14 minus 1 is 13. So 40m plus 13. Okay? This is h of g of x, so I'm going to start with h, which is 2x minus 1. I'm going to fill in g, which g is going to be x squared minus 4. Actually, I'm sorry, this is the exact same problem that this is. Okay, so don't worry about number 8. You can skip that. All right, it's the same problem. It's the exact same thing. Okay, so if you wanted to actually, you know what, let's actually finish that. So that would just be 2x minus 8 minus 1, so that's 2x squared minus 9. Okay? All right, moving on to the last two. This is h of x. So what I'm going to do is I'm going to start with the h function, which is 2x minus 1. Okay? Now, I'm going to replace it with 2x minus 1. So I distribute that. That's going to be 4x minus 2 minus 1. The minus 2 combines there, which is going to be minus 3. G of h of a half. So I'm going to start with the g function, which is x squared minus 4. I'm going to fill in the h function, which is 2x minus 1. And then what this is telling me is go to the calculator. So I'm going to make my fraction, ABC, 1 over 2. Hit over arrow for x. 2x minus 1 squared minus 4. And that calculation comes out to negative 4. Okay? Moving on. Question 10. Okay? So we got to use the pictures. This is the g function. This is the f function. Okay? So, when I'm doing f of g of 3, what I'm really doing, okay, is I'm going to evaluate this first. It's like almost like working backwards. So, g of 3, okay, here's 3. This leads to 2. So now I have f of 2. Okay? So I come to 2. 2 leads to 5. Okay? This one would be g of 6, so I would do f of 6 first, okay? So f of 6 leads to 1, then it's going to be g of 1, 1 leads to 4. Explain why g of 2 doesn't exist, okay? So g of 2, 2 leads to 5. But when I come over here, there is no 5 for the x value for f. Okay? All right? Inverse functions. Now, the big thing we want to do with inverse functions, and let me go to the back end of this because I want to really explain this. All right, we go to the blank. So for inverse functions, first thing we want to do is pick the inverse function. All right? Now, for x squared, going back and forth, that would be the square root of x. X cubed would be cube root of x. Okay? X to the fourth, obviously would be the fourth root of x. If you get an x of just no exponent, that is still going to be an x. So it's still going to be a line. Okay? Then, the big thing with the numbers, inside goes to outside, outside goes to inside, and you change signs for both. Okay? Alright, so whatever's inside is going to go outside, change signs. Whatever's outside is going to go inside and change signs. Okay? So let's go back to this example. Okay? Alright, so I got 4x plus 5. What this is going to be is this is plus 5 outside. This is times 4 outside. Okay? So, what I'm going to have is my function is going to be, I'm going to start with x. Plus 5 is outside, it's going inside for minus. This is 4 times the outside, so the opposite would be 4. Alright, so probably what I need to do instead of changing signs, sorry, that wasn't the right thing to say. What I should do is opposite operations. Okay? So addition turns into subtraction, subtraction turns into addition, multiplication turns into division, division turns into multiplication. Okay? I didn't specify that appropriately. So let's go back here. Okay. Alright? So what I would do is this is a 1. So very simply, I would just do 1 divided by 4, which is whoops. So if you hit fraction decimal, it's 1/4. Negative 5 divided by 4 is negative 5/4. So I got 1/4 x minus 5/4. Okay? Okay, this is, alright, this would be still x. This would be, instead of minus 15 outside, would become plus 15 inside. Okay? Alright? This is 3 times the out, 5 divide by the out. So the opposite of that would be 3 times the inside, which I would have to do to both, and 5, I'm sorry, that's not correct. I would do, 5 times the inside for both, and 3 divided by that. Okay? Alright? So what I would have is 1 times 5 divided by 3. So that is 5/3. 15 times 5 divided by 3 is 25. Okay? So, what I have is 5/3 x plus 25. Okay? Alright? This one will be pretty simple for the inverse. And this is the symbol for inverse, by the way. Alright? That would be square root of x. This is plus 1 outside, so it would become minus 1 inside. Okay? This inverse, a lot of these are going to be pretty quick and easy to do. This would be cube root. This is plus 7 inside, minus 2 outside. This is, whoops. This is minus 3 outside, plus, minus 3 inside, plus 3 outside, plus 4 outside, minus 4 inside. Okay? This would be 4 times the outside. Alright? So what I would have here, okay, I would have square root, okay, this would be x, minus 7 outside would become, minus 8 outside would become plus 8 inside, plus 7 inside would become minus 7 out there. This is 4 times the outside, so the opposite of that would be 4 divided by the inside. You can just leave that, okay? In this last example here, this is 2 times the outside. Okay, this is 2 times the outside. So what I would have here, okay, that's plus 5 outside. This would become minus 5 inside. This is 2 times the out divided by 2. Okay, 18, use composition to show that they're inverses of each other. Okay, you can really do this a couple different ways. All right, what I'm going to show you how to do is just simply the inverse of this would be x squared plus 3 would be minus 3 here. Okay, this would be square root x minus 3. As you can see, they're not the same, so this answer would be no. Okay, this right here, all right, would be x, okay, plus 4 outside, minus 4, all right, and then divide by 3. Okay, so that's going to be 1/3 x minus 4/3, which matches that. This would be x plus 4/3. Okay, this would be 1 times the out, 3 divided by the out. Okay, so the opposite of that would be 1 divided by both of those. Well, 1 divided by 1 would be that. 4/3 divided by 1 will still be 4/3. Okay, now 3 times, so I want to multiply those by 3. 1 times 3, which would be 3. 4/3 times 3, which would be 4. So 3x plus 4. So that answer is yes. Okay, all right, so which ones are true? Okay, all right, that would be true, this would be true. This would be false. They're not always. This would be true. I'm sorry, this would be false. Okay, this should be positive x. If the domain is this, then the range should just be infinity and 3. So this is also false. Okay. All right, determine the inverse. Okay, if f of x and g of x are inverses, well, what I would do is you look at a couple points here. Actually, you know what? Let's stay up here and do this. Okay, given the 2x plus 7, 2x plus 4, graph and label on this axis. So 2x plus 4. Whoops. 2x plus 4, what I would do is go ahead and graph. Draw. G solve root, -2, 0. And then G solve, I'm not going to have a max. I'm not going to have a min. I'm not going to have no minimum. G solve y-intercept 0, 4. So this is the first one. All right. So the idea here is that that's -2, 0, and that's 0, 4. When you do the inverse, now this is with points, these just flip around. So 0, -2, 4, 0. We'll graph that in red. 0, -2, 1, 2. 4, 0, 1, 2, 3, 4. That's what I have. Okay? All right, so that leads us down here. What you would do, all right, is look at, this is 2 over 1, 2, 3, 4 up, about 5. Let's say this is here, 2, 5. Okay? All right? This also crosses at like 1.10. All right? So the idea here is if I flip this around, this should be 5, 2 and 0, 1.1. And as you can see, if I go 5 over 2 up, it's nowhere near the picture. 0 over 1 point up, so this is no. These are not inverses. Okay? So this one, they want us to graph it. Okay, so I'm going to use these points again. Use the anchor, I'm going to use this. The points I normally use for graph, so that would be 1, 2, 3, 4, 4, negative 1. This would be 3, 0, and 0, 1 would be over here. So when I graph the inverse, I would graph 1, 0. I would graph 0, 3. And I would graph negative 1, 4. Okay? So what I got that. Okay? 25. Now, the big thing here that you have to understand is that exponentials will create y equals asymptotes. Logs will create x equals asymptotes. Now, how do you get those numbers? If you look at the anchor point here, this anchor point would be negative 2, negative 7. So, my asymptote is at y equals negative 7. 1, 2, 3, 4, 5, 6, 7. Okay? Would be right here. So, what I'm going to do, let me use these other markers because it's a little bit easier. 1, 2, 3, 4, 5, 6, and 7. So I'm just going to draw a dashed line right here. Okay? Alright? Okay, so that's where my asymptote is going to be. And then what I'm going to do is I'm going to go ahead and graph it. 3, to make the exponent, I hit this little arrow, x plus 2, minus 7. Draw. As you can see, it goes through there. So we're going to find the same stuff. G solve root, negative 1.2. Or negative 0.2 would be right about there. Okay? G solve y-intercept is at 0, 2. And the idea behind, and if you want to do G solve, there's no max. Okay? There's not going to be minimums on this. Okay? So what's going to happen is this graph is going to approach the asymptote and then go through those points. Okay? So that's how you interpret the picture. Okay? Is it approaches this pink line and goes through those points. Contrary, my anchor point here is negative 0, negative 4, 0. So my asymptote is going to be x equals negative 4, which is 1, 2, 3, and 4. 1, 2, 3, and 4. So it would be right like this. It's not good. Alright. Okay. So what I want to do, alright, is I want to go in now and do the log function. Okay. Log function is option. Okay. The way you get to the log function is you go option, then you go to calc, and then you pick this little log AB. And what you do is you put 2 there, x plus 4 here. Draw. Alright. G solve root. My root is negative 3, 0. G solve, you're not going to have a minimum, you're not going to have a max. The y-intercept is 0, 2. So negative 3, 0, and 0, 2. Alright? And so now the graph approaches the pink line and does something like that. Okay? Alright? Here, my anchor point would be 0, 8. Okay? So my asymptote would be y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright? Then what I'm going to do is I'm going to go in and graph that. Oh, whoops. So if I draw it, that's what my shape looks like. G solve root, 3, 0. Alright, G solve y-intercept, 0, 7. Now this one here, my anchor point would be negative 2, 4. So my asymptote is going to be x equals negative 2. Okay. Once again, option, calc, log AB. 3, x plus 2, plus 4. All right. G solve root, negative 1.98. So like almost 2, right about it there. Okay. And G solve y-intercept, which is at 4.6. 1, 2, 3, 4.6. Now the idea is make sure your asymptote always approaches that pink line. Don't stop it even though the graph looks like that. Okay? Alright, now this stuff we're going to have to go ahead and find all of these things. Alright? So this anchor point is going to be 0, 9, which means I'm going to be at y equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright? Negative 3 to the x power plus 9. Draw. Okay. All right. G solve root is at 2. G solve y-intercept is at 8. Okay, and this is what my graph looks like. Now, when I go to label this, okay, normally I label arrows like this, okay, left arrow, right arrow. What you got to do is look at which one approaches the pink line, which is this one. So whatever number is here is going to go here. Everything else, because that's a y, this is a y. Everything else I fill in the same. So that's a left arrow, this is a right arrow, and this is going down. Okay? So my 0, I already found that was x equals 2. So this would be x equals 2, x equals 2. The y-intercept was y equals 8. I did not have a vertical asymptote. This is horizontal at y equals 9. Okay? Increasing, decreasing, still start from the left. This is decreasing the whole way from negative infinity to infinity. Okay? There is none of that. Okay? Now, as x approaches infinity, that's going to be negative infinity. Okay? As x approaches negative infinity, the answer will be 9. Okay? Now, the domain, okay? My smallest x value is negative infinity. My biggest is positive infinity. There's only 2 to label. Okay? All right, another word for that is all real numbers. Okay? That's all real numbers. Now, my range, my smallest y value is negative infinity. Now, my biggest y value is 9. Now, since 9 comes from this dashed line, I can write 9, but that 9 is going to be curved because it comes from the asymptote. Okay? All right, let's go to this one. This anchor point will be negative 3, negative 2. 1, 2, 3. Okay? We'll go right through there because we're going through x equals negative 3. Okay? Now let's go ahead and graph that. Option, calc, log AB. Okay, 3, x plus 3, minus 10. Okay, so G solve root, answer is 6. All right, G solve y-intercept, answer is 0, negative 1. Graph will look like this. Okay, so when I label this arrow, okay, all right, because this equation is x equals negative 3, that means that will be that. Everything else will be the same. This is infinity, infinity. And this would be negative infinity because it's pointing down, okay? So 0 is x equals 6, y equals negative 1. I believe that's what I got, right? Yeah, okay. Vertical asymptote at x equals negative 3. We didn't have a horizontal asymptote. I start from here. This is increasing the whole way. It's going to increase from negative 3 to infinity. Okay? It's not going to decrease at all. Okay, as x approaches infinity, which is here, that's the y. Alright, as x approaches negative infinity, that's going to be none. As x approaches negative 3, that's going to be negative infinity. Now, for my domain, my smallest x value is this, the biggest is this. Once again, since it comes at an asymptote, I can put a curved bracket for that. And my range, my smallest y was negative infinity, and my biggest was positive infinity. Okay, write an equation of an exponential that has a range of that. So what that would mean is my smallest y value, okay, big y value. So in order for that to be, my thing would have to go like this, because then that would give me this, okay, negative infinity, 2, okay? So how do I get that? That means that my asymptote would have had to been at 2, and I'd have to have a little negative out front, okay? All right, moving on to 32. These are review questions. Make sure you do these, okay? That's going to be negative 4, negative 2, infinity, infinity. Smallest x value is negative 4. Biggest is infinity. Smallest y value is negative 2. Biggest is infinity. Now, that comes at a point. That's why those are boxed in. Zeros. Crosses at x equals negative 3. That's the same answer here. This crosses at y equals 2. Okay? Start from here. This is increasing the whole way from negative 4 to infinity. Decrease will be none. Okay? And behaviors. X approaches infinity. Y approaches infinity. As x approaches negative